Okay, so now we're crossing over into this evaluating your measures. So I've called this construct validity. When you're evaluating the quality of your measure, you're evaluating the validity of your measure. Reliability is the first thing we're going to talk about. It's one aspect of validity, it's part of validity, and it's a very big part of it because it allows you to be able to say that at the very least I'm consistently measuring something. But it's only one piece of it. Validity requires multiple things in order for you to say that a measure is valid. So a bit of a forewarning here. I focus on reliability quite a bit, but that's only one piece of the overall validity question when it comes to measures. Another point to make before we go through this material is that validity, I had alluded to this earlier, can refer to the validity of a research design. And so embedded in the evaluating the validity of a research design is questions about the measures. Are the measures valid? But that's not all that you consider. It's only one piece of validating your research design. And so now we're sort of focusing in on the validity of a measure. And it's a very important piece because, as I alluded to earlier, measurement, if you don't understand the details of how things are measured, you can jump to conclusions about results before you really understand what's going on. And so, with that, let's talk a little bit about the types of things that we evaluate when we're looking at measures. So the first is reliability. Is the measurement process consistent? Is it free of randomness? The other is bias. Is your measurement system giving you a signal close to what it should be giving you? Is it free of this, what we call systematic error? The best way to understand these concepts is to look at a visual. So here is what reliability and bias look like. So if you have a measure that's reliable but biased, you'll be hitting a target in the wrong spot, but you'll be doing it very consistently. So you're zeroed in on this clumping right here. So this is actually not a bad place to be, because if I can quantify the distance between this target and the center of this clump, I can do an adjustment, and I can be consistently adjusting so that my measure ultimately gives me what I'm looking for. So being reliable but unbiased, we can deal with it. But biased, we can deal with it. When you're unreliable and unbiased, we really can't do anything. Essentially, every single measure is giving you something different, and so you can't extract any truth from it. When you move to unreliable but biased, we're in a similar problem. We know that our tool is somehow missing a big chunk of the story, but the part that it's actually describing is still very random, so we can't really do much with that either. Ultimately, what we're striving for is reliability and unbiasedness, and this is how you get valid measurement. So there are many types of reliability coefficients, but in general, reliability is the correlation between scores on individuals who are measured twice. So we think of giving a test in a class, leaving the room and somehow magically erasing their memory of ever having taken that test, going back in and giving them the test again. The correlation between people's scores on the first test and the second test would be an indication of how consistent our measure was, how reliable our measure was. And this is what this hypothetical data might look like. So imagine a situation where we went in, tested people, erased their memories, tested them again, and we got the first figure on the left here. Test 1 scores, this person had a high test 1 score, so very far on this side of the scale, but a very low test 2 score. And it's all over the map. Essentially, you cannot predict what a person will do based on test 1 scores. So this is a highly unreliable situation. Alternatively, over on the right, we see test 1 scores predict pretty well what you're going to get on test 2. There's some, some variation, and this is due to what the test taker's bringing to the table. From one moment to the next, there may be differences in their ability to focus. And so on test 1, they performed better than on test 2, or on test 2, they perform better than on test 1. But essentially, this is a highly reliable situation where test 1 is very consistent with test 2. So there are many types of reliability coefficients. We'll talk about 4 here today. The first is test-retest. Test-retest is where you administer a test, go back, administer the same test again. That strategy is a little problematic because people will maybe learn in between administrations. They may also remember the test that they took and be able to improve based on that. And so there's all these variables or factors that limit us from being able to assess true consistency. Plus, it's very hard to bring people back a second time. So then people came up with another version called alternate forms reliability. So we may have a situation where we administer 2 versions of our test and do it at the same time. So we create test 1 and test 2. And we think they're measuring the same underlying construct, so they should produce similar scores. And we administer it to the people at the same time because they can't come back to do our study a second time. So what we end up having is something called a coefficient of equivalence. Coefficient of equivalence is when there's no history getting in the way. We know that the time between administrations is minute, and also the forms are basically, we're assessing how equivalent the forms are. Another version of alternate forms is when you do 2 versions of the same measure administered at 2 different times. And so the advantage of this, it's a more rigorous assessment of reliability, is that you're assessing stability or consistency over time as well as over 2 versions of a test. And so this is something they call the coefficient of stability and equivalence. But we're still in a world where we're administering 2 tests, which is cumbersome and not realistic, and oftentimes we have 1 shot. And so is there any way we can assess reliability with one test? Yes, it's called the internal consistency measure of reliability. And essentially, this is a version where you're taking your 1 test and splitting it up into 2. So the first is a simple split half reliability coefficient, where we are taking our test, splitting it in half. The odd questions, we compare the scores on the odd questions to the scores on the even questions, and if they're consistent, we have high reliability, and if they're not, we have low reliability. So the only problem with that is, how do you split up your test? Well, to overcome that, we came up with these homogeneity measures of reliability. And these are basically the idea that let's look at all possible combinations of the test and calculate the consistency for it, and then come up with that overall average consistency. And it's all done in one intense calculation, but essentially it's this idea of, if we could put all the different possible combinations of a test on the table and calculate the reliability and then calculate the average of those reliabilities, what would the overall consistency be? And so there's 2 versions of this. The one you're going to be most hearing in the literature is something called Cronbach's alpha. And most statistical packages will calculate this for you. So the last type of reliability coefficient is the inter-rater reliability coefficient. And this is a coefficient that we talk about when we have multiple judges involved in producing scores for an individual. So you'll see this a lot in the health science education world, where we use rubrics and we have multiple people observing someone and then scoring them on something. Well, we could take the scores of the 2 judges and calculate a correlation between them, and that would tell you how consistently they were ranking the individuals. Alternatively, we could calculate the proportion of times they were agreeing. So take the scores, simply assign a 1 if they agree or a 0 if they don't, and calculate the proportion of times they were in agreement. That's called the coefficient of agreement. And that's often all that's reported. The problem with the coefficient of agreement is if there's only 3 or 4 levels that you can score a person at. So oftentimes you've got a rubric or a scoring scale that has 4 points on it, 1, 2, 3, and 4. Because there's only 4 points to assign, just by chance alone, you have a good possibility of agreeing. You're likely going to either be on the high side or the low side. So you're down to a 50-50 chance of agreeing perfectly. And what these coefficients of agreement that calculate proportions of agreement are susceptible to is they don't account for the chance levels of agreeing. So you get this inflated sense of reliability. And so that's where the coefficient kappa comes in. So coefficient kappa is an index that says, yeah, we may have seen a lot of agreement, but how much of that was due to chance alone? So it adjusts for that. And it's a more conservative estimate of reliability. So there's a lot more information on each of these types of reliability coefficients, and these next two sets of slides provide and detail a lot of that. I'm not going to spend time going through them. I will post this information in a slide deck on eClass, and I'd encourage you to read through this. Also, this is the second slide, so a little more information about the internal consistency reliability coefficients. So please read these two slides in your own time. Here's just an example to demonstrate the inter-rater reliability issue. So if we look at the crosstabs between these two raters, so they had to decide, did this person pass or did they fail? 32 out of all the times they observed them, there's 100 cases, 32 were perfect agreement. 32 plus 23, because 32 times they agreed that the person should pass, and 23 times they agreed that the person should fail. So that equates to a 55% agreement rate, or proportion of times they agree. Given that there were only really two choices, the coefficient kappa, if you calculate and account for the fact that there's chance levels of agreement, is 0.11. And kappa is an index that ranges between 0 and 1. The closer you are to 0, the less reliable you are. The closer you are to 1, the more reliable you are. So this data shows that despite the fact that we saw 55% of the time they were agreeing, their consistency is quite low. Okay, validity of measures. So again, validity of measures is one piece of research validity. Reliability is one piece of measurement validity. So there are these different levels you have to be aware of when you're talking about evaluating reliability and validity, and also evaluating research. So we're talking about measures and the validity of a measure. Well, validity, when you're talking about measurement, is this fundamental question of, are we measuring what we think we're measuring? Ultimately, it's not a property of a test. It's a property of how we interpret the test scores. So validity is about judging the inferences people make from a test. And we're trying to assess whether or not that inference is valid or invalid. And so we need to know the thought process that gave rise to an inference. We need to evaluate that thought process. We need people to tell us and bring evidence to the table that justifies their thought process behind their inference. So how can they do that for us? Fortunately, people do a lot of work in this area, and they've outlined a framework that helps to guide the evidence that needs to be brought forward. So we have this one idea of validity. We talk about the validity of an inference, and we want evidence to justify that inference. So we ask people to tell us evidence based on test content. This is where you go out and you have experts review your tool, and they are experts in the area. They give you feedback, they revise the content, and they also tell you that yes, this does appear to be measuring what it is you think you're measuring. So you engage in an expert revision process, and the more that, if you see people discussing these types of things in their literature, that's a good sign that they've at least thought of this step. They also need to generate evidence about response processes, and this is really important for educational tests and measures where you've got a measure of performance. You need to show people, if you're creating a measure, that the thought process they work through as they solve the problem is the thought process you intend for them to work through. So a good example is a multiple choice exam. a lot of times people can find the right answer to a multiple choice exam question by using test-wise skills, eliminating alternatives based on wordings of the questions, and that's not the thought process that should be brought to the table. In fact, that's an invalid thought process. So people who do successful based on their test wiseness skills are actually going to come out as having a high level of ability, when in fact that wasn't what we actually measured. We measured something else. We measured test wiseness. And so you would have to do something like have a test taker work through the measure, the ability measure, whether it's a math test or whatever, and think out loud while they're solving the question so that you could assess whether or not they're engaging in the right processes. Next, you have evidence based on internal structure. So this is reliability. So of these 5 things, reliability is only one of them, and it's all about this internal structure. So is this a reliable measure? Is it measuring one underlying construct as opposed to multiple underlying constructs? So you can assess this using the Cronbach's alpha reliability coefficient. And if you have a low Cronbach's alpha, so again, Cronbach's alpha and most reliability coefficients range between 0 and 1. So if your reliability coefficient is close to 0, you don't have very good internal structure. You don't have a very valid measure. If your reliability coefficient is close to 1, you have a very reliable measure. And so you've checked off this piece of evidence. But it's only one piece of evidence to check off. Then we have to move on to evidence based on relationships to other variables. This is a very important piece. So essentially, you're telling a story where you've measured intelligence, or you've measured motivation, or you've measured whatever it is. There's a lot of literature on both of those constructs, and that literature defines things we would expect to see, relationships we would expect to see. So in order to convince people that you're actually measuring intelligence and motivation, you need to demonstrate that those relationships that have been established exist. So there should be a positive relationship between intelligence and success. Then you have the final one, evidence based on consequences of testing. So this is a good way to think about this is you may be using a tool to decide who gets into a program versus who doesn't. So as a consequence of using the tool, some people are limited access to a program. Is it true that the people who were given access succeeded? And is it true that the people who were not given access were rightfully excluded? And so you have to evaluate or provide evidence to suggest that the consequences of using the test are valid. Okay, so lastly, I provide a description of a measure from a journal article as an example. This is a really good description of a measure because it gives you a sense of what the definition, the nominal definition of depression is, the operational definition of depression, the reliability within different groups. And so I've provided this as an example so that you can see what to look for in literature that you read in order to be able to, number one, see that there's evidence being presented to you. And then number two, also be able to evaluate that evidence and say whether or not it's good enough. So this is what you should be striving for as you write your literature, these kinds of descriptions of your measures, and this is what you should be looking for as you evaluate the literature. And that covers off today's screencast. I will be adding in a screencast on validity and qualitative research, which will be a part of next week's screencasts.